What's up, my pre-calc people? I'm Michael Project, and in this video, I'm going to go over the answer key to the section over complex numbers that you can find in the AP Precalculus Prerequisite Skills Practice Worksheet. You can access this worksheet completely for free in the ultimatereviewpacket.com. Link in the description below. It's got everything you need to be ready for AP Precalculus. Let's dive into solving these problems right now. All right, let's talk about how to simplify expressions involving I, the complex number. So complex numbers are numbers that are part real, part imaginary. So we have A plus BI. So A is the real part, B is the imaginary part, and of course I is the square root of -1. All right, so when you're adding complex numbers, all you gotta do is add the real parts, add the imaginary parts. It's that simple. So 3 plus 5 is 8. 2i plus a -6i is -4i, and just like that, we're done. All right, over here we're subtracting, so just be careful when you subtract. You have to subtract everything after the minus sign, so we get 4 plus 5i minus 2 plus 3i. Don't forget about that. So combining our real parts, 4 plus -2, we get 2. 5 plus 3 is 8i. Done, simple, very easy. All right, now when it comes to multiplying, we just got to be careful. All we got to remember is that I squared is just -1. Because remember, this I is the square root of -1. So when you take the square root of -1, you square it. The square cancel, you just get -1. So let's go ahead and multiply this slowly. 3 times 2 is 6. 3 times 4i is 12i. -5i times 2 is -10i. And -5 times 4i is -20i squared. All right, now we have 12i and -10i. Those are our imaginary parts, which is of course just going to be 2i. Now, remember, I squared is equal to -1. So we have -20 times -1, which is going to make a positive 20. With that 6 in front is going to be 26. So that -20i squared becomes a real number when the I squared turns into a -1. Just make sure you don't forget to make -20 a positive 20. Combine it with that 6 to get 26. All right, on this next one, we're just going to do a little bit of distribution. 4i times -2 is -8i. 4i times 6i is positive 24i squared. All right, so the I squared is, of course, going to turn into a -1, making that a -24 real number minus the 8i. There's my complex answer, nice and easy. All right, for these final two problems, we got to deal with getting rid of the I in the denominator. Because remember, I is a square root. We don't like square roots in the denominator. So it's a pretty common process here. What we're going to do is we're going to multiply by the conjugate. A lot of kids don't understand this or kind of forget how to do this. It's really, really easy. So we're going to multiply by 2 plus I over 2 plus I. So essentially, we're multiplying by 1, not changing how it not changing what it is. We're just multiplying by 1. We're changing how it looks. But this is a conjugate. Multiplying by conjugates is really simple. The conjugate of A plus B is A minus B, and vice versa. A minus B, the conjugate's A plus B. So why is this going to work? Well, watch out. All right, first let's do the denominator, or the numerator. Let's do the numerator first. 3 times 2 is 6. 3 times I is 3i. 7i times 2 is 14i. And 7i times I is 7i squared. Now in the denominator, check this out, 2 times 2 is 4, 2 times I is 2i, -I times 2 is -2i, and -I times positive I is -I squared. Now the awesome thing about multiplying conjugates is that the inside and outside terms are always going to cancel. So that 2i and -2i are going to reduce to a 0. And in the denominator, I just get 4 plus 1. Where did I get the plus 1 from? Well, remember, I squared is a -1. So -I squared is going to become a positive 1. And that's why I get a final number 5 in the denominator. Now, in the top, I have a 3i and a 14i. That's, of course, going to make a 17i. But once again, this I squared is a -1 times the 7 makes a -7. Combined with that 6 is going to get me a -1 plus 17i. So my numerator is -1 plus 17i. Now, we do like to split this up so there's a real part and imaginary parts. We kind of prefer to write this as -1/5 plus 17/5 I. So basically we're dividing everything by 5. -1 divided by 5 is -1/5. 17i divided by 5 is 17/5 I. And in similar fashion, this final problem, we're going to multiply by the conjugate, 3 minus 2i, divided by 3 minus 2i. That way we could turn this into one simple complex number, real part, imaginary part. Once again, the conjugate of 3 plus 2i is at 3 minus 2i. So I'm essentially multiplying by 1 because I'm multiplying by the same number over itself, but it's just going to change how it looks. It's going to give me a nice final answer. All right, take your time in the multiplication. 5 times 3 is 15. 5 times -2i is -10i. Negative 8i times 3 is negative 24i. Negative 8i times negative 2 is positive 16i squared. All right, in the bottom we have 3 times 3, which is 9. On the outside we have a negative 6i. On the inside, 2i times 3 is a positive 6i. And then finally we have a negative 4i squared. Once again, the whole advantage to multiply by the conjugate is in that denominator. Those inside, outside terms are going to cancel. The negative 6i and the positive 6i are gone. They add up to 0. And then I'm going to get 9 plus 4. Where did I get plus 4 from? Once again, remember, I squared is a negative 1. Multiplied by the negative 4 turns into a positive 4. All right, in top, I have a negative 10i and a negative 24i, which is going to make negative 34i in total. This I squared is also going to turn into a negative 1, so 16 times negative 1 is negative 16, plus the 15 right here is going to make a negative 1. So I have negative 1 minus 34i, all divided by 13, 9 plus 4. Once again, we do like to write this as a complex number, real part, imaginary part, so we get negative 1/13 minus 34/13 I. So there's my real part, the negative 1/13, and my imaginary part, the negative 34/13 I.